Welcome to our pre-calculus lesson 19. In this lesson, we will discuss how to build some linear models from the given data. It means when some data is given or some graph is given, if that graph is linear, how can we find out from that graph some equation? Okay, how can we find out some function from the given data or from given graph if they represent linear progression, linear relationship? Then how can we find out some equation from that? So this is our target for today's class, and these are our agenda. First, we will review how to find out if some data is linear or non-linear. We will try to find it out. Then this is a scatter diagram. From a scatter diagram, we will try to understand if the given scatter diagram is linear or non-linear. And then other topics are related to how to find out that model from the given data. Okay, model means linear function or any kind of function basically, but in this class, since the class is related to linear, so it is linear function. Model means the equation or function that represents some real life thing, that is called model. Okay, let's go. So from this given data, actually this is a recap from our previous lesson. Previous lesson also we discussed this thing. Just a recap, this data and this data, which one represent linear, which one is not linear. To find it out, you have to look at x value and y value, x value and y value for this graph, and x value and y value of the graph. One of the clue is, main thing is the average rate of change will be constant if it is linear. Average rate of change will be constant if it is linear. That means slope will be same for all the points. For all of them, slope will be same if it is linear. And if slope is not same, then it is non-linear. Okay, and one easy way to understand if slope is going to be same is we can just look at the x value and y value. If their difference is same everywhere, then slope is going to be same. So you see here, the difference between these two numbers is this difference between these two numbers is this, and you can see they are not same. That's why it is non-linear. And if you draw a graph, see, the graph is not linear. It represents some curve. See, it represents some curve, curve. So it is not linear. And this one you can see difference is same everywhere. This number minus this number equal to this number minus this number equal to this. So difference is same everywhere. That's why it is linear. And if you draw a graph based on this data, then you will get a straight line. If the data is representing some linear thing, then if you draw it, it will definitely it will be some straight line. Okay, so it will be some straight line. So this is the recap from which one is linear and which one is non-linear. Now we have this thing. You may think like, what is a scatter diagram? A scatter diagram is, in most of our previous lesson, we found most of the time our point is like on the line. This is a point. This is a point. Suppose this is a point like this. So like this was our regular graph. But our in our real life data, they are not like that. Some values may scatter. Some values may scatter, which is like this. Some value may come here, some value is there, some value is here, some value is there. Like the values are scattered, not in the same line, not on the same line. They are scattered. They are in different places a bit. If that is the case, then we will call this is a scatter diagram, this is another scatter diagram, this is another scatter diagram. Okay. If the given points are scattered, then it is a scatter diagram. Okay. Now what we will do is we will look at the general shape, a common shape of the line. We will look at that. Say if you look at this, see the common shape of the line is like this straight line. I mean straight line, some straight line like this. See, if I block all of them, if I block all of them, then basically it looks like a thick straight line, a little bit thick straight line, and we can actually approximate all of them to a very thin straight line going through the center. We can draw a line like this, and we can say that average, this is the average of more or less all the points. Okay, so this way we actually can find out what is their average, kind of more or less approximate uh, uh, relationship among all this data. This axis and this axis, what is the relationship here? So this is how we can actually take their average. But in this case, our question is to find out if these given data, they are linear or non-linear. Okay, and already you know, linear, if it is linear, then the line will be straight line. If it is non-linear, then it will be curve. So how can we find out that? We have to go for the concept that I said, average relationship. This one's average relationship looks like a straight line. First you think about this, which one can be linear and non-linear. I think now you have got some concept. This one looks like a straight line, so it must be linear. This one average shape is curved, so not linear. This one also average shape is like this, so not linear. This one's average shape is straight line, so this is linear. This one's average shape is like this, so not linear. Curve means not linear. This one's average shape is like this, so this is also a straight line, so this is linear. So from these three linear, this one, and this one, what do you think? What will be the slope of this line? Just idea. What will be the slope? Is it positive number or negative number or 0? What do you think? For this one, you can see this is the increasing line. If you recall it from increasing function, decreasing function, it is increasing. So the slope has to be positive, must be positive. And this is decreasing from left to right. If you go from left to right, it is decreasing. So this one's slope is negative. And this is a horizontal line, so this one's slope must be 0. Okay, horizontal line slope is 0, vertical line slope is undefined. You know that. So positive slope means what? Positive slope means greater than 0. Positive slope means greater than 0. Negative slope means less than 0. And then this one is slope equal to 0. So what does it mean? It means that if the points are scattered like in different places, then we can draw a line through the middle of them, approximately middle of them. Then from that line, from that line, if you can choose some points, suppose you can say, okay, this is my point. You can choose from yourself, no problem. It's no problem. And then you can choose this point. Then actually you can find when you choose 2 points, then you will have their coordinate, like x below, y below, what. Then you can actually find out their slope, actual slope also you can find out this way, which we will do in the next page. So we can find out slope from this kind of thing. These are the only 3 which are linear. Okay, so these 3 are linear. So see, this is the runs scored versus on base percentage for the National League 2008. 2008. So these are the some scatter diagram. These are some scatter points. This point here, this point here. There is no no very clear cut relationship among the points. Okay. So what can you do is our main target is what? Main target is to find out linear equation for this given uh, points, a linear relationship, uh, equation of a straight line. Equation of a straight line. We want to find out equation of a straight line. Now it looks like this is not a straight line, but if you look at the average shape, average shape looks like a straight line. If you draw a band, these people puts a band in their hair band. Hair band is what? Hair band is little bit thick, right? So if you draw a band here, then they will represent some straight line shape, and if you can draw a line to the middle of that, then that will be the average of all the points, approximately, of course. Let me tell you one thing about this. Let me draw and then tell, so that you can connect. So suppose you draw a line like this, then you can say this is my approximate line. Other student can say, sir, there are some more points here. Can I draw a line like this? And is this my this is my answer. So then you come to us, then you say, sir, she said this one is right, and I'm thinking this one is right. Sir, which one is right? Actual answer is both of them is right. Okay, because you are drawing some approximate graph. Approximate graph means you have to think about which line fits like to the middle of all the points. A very standard technique is suppose if you have 1 point here, 1 point here, 1 point here, 1 point here, 4 points suppose. So the technique is you have to draw lines such a way so that equal number of points is up and equal number of points is down. Your line goes through the middle. Okay, so this is one approximately correct line. And another correct line, we can draw another correct line. So see, another correct line is more or less this one. This one is also correct. Now what I have done here is I have connected 2 points here, and the other 2 points are, this point is up of my line, this point is down of my line. So this is average is going to the middle, and we connected these 2 points. Now the better, this is not, of course this is not 100% solid, but both of the line is correct. I'm just trying to say this. So your answer will vary. My point is your answer will vary in this kind of math. Some people's answer will be, they may say, sir, slope is, my slope came, let's say 0.75. Other people can say, sir, my slope came 0.8. So other people can say my slope came 0.72. Of course it will be very close. Let me show you some incorrect graph. Suppose if you draw something like, let's say you draw a line to the middle. This is definitely incorrect, okay, because you can say, sir, same number of point this side and same number of point that side. So is it correct? No, it's not correct, because it is not following the trend of the data. Data is going through this point. All the data is like this band within these 2 lines. So your base fit line has to be through the middle of them. Okay, graph, your straight line has to be to the middle of them. So this kind of very this is quite weird line. This line is not possible. Okay, we have to follow the trend of the data. This is my point. So what I said about so far is we have to follow the trend of the data, and your answer may vary. People's answer will be different from each other, but it will not be too much different. Suppose some people's answer slope came 1.2, another people's slope came 3.5. This is not possible, and you will see why. Because then at that time one line will be like this and another line will be like that. Huge gap. Suppose this one's slope is 3, this one slope is 1.1 or 0 point something, then the line is too much different. Okay. So the answer will be close to each other. Let's come to the points now once again. So these are the given points. This is the given scatter diagram. We have to find out the equation of a straight line. So what we have to do is, first of all, we have to choose 2 points, 2 best points, or first you can draw the line also. From the line you can choose the points also. In this case we have chosen these 2 points, this point and this point. We have chosen because it looks like if we draw a line through the middle, like that, through the middle, then that line will represent all the data. Yeah. You can choose some other. Suppose you can choose this point and this point also. They are also close. This point and this point, very close to the line. So maybe you can choose this point and this point also. If you choose this point and this point, then you have to draw the line through that. Let me show you. So we have chosen this point and this point. That's why our line connected these 2 points, this one and this one. Our line connected that 2 points. So if you choose some other point, suppose if you choose this point and this point, then your line has to connect these 2 points. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So you see, in our graph intersected 2 points from the data, and exactly 7 points is on the up of the graph and 7 points is down of the graph. This is the main structure of best fit line. Your straight line's main structure is this. You have to draw the line in such a way so that your line represents the data, and since it is a scatter diagram, so there will be some points up and there will be some points down, and your task is to draw the line such a way so that above the line and below the line there will be exactly same number of points. That is your target. If you can draw like that, then it is 100% correct. And if, like, suppose here 6 comes, here 8 comes, then it is not accurate. But you may get marks for that also, because that also sometimes when there are many points, then you have to approximate for real life situation. I'm just saying. But this is the exact structure. How can you draw the best fit line? Okay. Some points your line will go through, and then from the remaining points, exactly same number of points will be up, same number of points will be down. Then it is best fit line, and from that line you have to find out the equation of line. When you have that line, you can find out the equation of line. Now see, in this math we have chosen 2 points from the given data, 1 point here and 1 point here. We have chosen these 2 points. But if you think that you can choose some other points from the straight line, suppose you can choose this point and this point also from the straight line. Let me draw it here on the line. Suppose you think that, okay, this point is on this horizontal line and this point is also on this horizontal line. You want to choose these 2 points and find out the equation of straight line. You can choose these 2 points also, no problem. But condition is you have to choose the points from the line. Okay. On this line there are many points, so you can choose any 2 points, then find out the slope between that 2 points, then use the equation of a straight line to find out this is the point slope form of the equation of a straight line. Formula is y minus y1 equals to m into x minus x1. So when you have 2 points, you can just directly find out the slope. Then when you have a slope, then you can actually put the slope here, and then x1 y1 you can choose any point for x1 y1, just you put it here, then the simple calculation then will give you the equation of the straight line. This is the model. This line is the model for what? This line is the model for this given linear relationship. Okay, when we say that find out the model, that means we are asking you to find out this equation from the real life situation. And why we are interested to find out the model? Because if we can find out the model, then we can predict about the some other value. Suppose if we say that, okay, this is 31.5, then 36.5. Okay, x value is 31, from 31.5 to 36.5, x value is here. Now if we have this model, if we have this equation, then we can ask you more questions, or you can ask us, or just simply we can answer more questions. Let's put it this way. Suppose we can answer the question like this. Suppose what if the x value is 40, then what will be the value of y? Then we can put the x value 40 here without looking at the graph. All these points is not given here. For 40, graph is not given, but now we can answer what will happen for 40, or what happened before this 31.5. Suppose 25, for 25 what happened? Okay, for 25 what happened? So we can just put here 25 and we can find out the answer. This is the benefit for model. When we have the model, we can answer a lot of other questions. We have more example like this. See, this is another scatter diagram. A lot of points, as I said. So that's why I said your answer will be different. Answer will be different. So we have chosen this point and this point. In this case, you could choose some other points also, but you have to choose such a way so that your line is your point is matching. Approximately, it is correct. So what is the first task? First task is to choose 2 points which will represent your data, or which will be on the base fit line, and it should be accurate more or less. Then find the slope between them. Find the slope between these 2 points. Then slope is here. Then find the equation of line. How can we find out the equation of line? By using y minus y1 equals to m into x minus x1, that form, which is here. Then you do the calculation, you get the model. This is the model, and this is the base fit line. This line is called base fit line. Base fit line is really important for practical life situation, real life situation. Base fit line is important because in real life, that very nice straight line do not come in real life. Now here we have another example of the same thing. So now very less data, so that this kind of data you can try and solve. What will be the base fit line? Give a try. Okay, give a try. Then we will show you the some sample solution. Okay, you try to find out the base fit line. This is a little bit easy. Give a try to find it out. And then I will now show the answer. If you need more time, you can just pause the video and come back later when you are done with the calculation. So we have chosen these 2 points. No worries if your points is little bit different. Suppose if you choose this point and this point, then your answer, suppose our slope came 0.15, maybe your slope will come minus 0.13 or 16, like that. Okay, but it will not be too much different. So we have chosen these 2 points, this point and this point, and we have tried to found our calculation. From the calculation, 0. minus 0.15, this is the slope, and then equation of a straight line is minus 0.15 plus 0.35. 0.35 is this point. This is the y-intercept, you can see. So this will automatically come here, or just directly you do the calculation from and you will get some equation somewhat similar to this. Okay, now interpret the slope here. What is the there is no part C here. Actually, I can remove this C from here. So interpret the slope. What is the slope here? What happened here? Let me explain this part. This part is a bit interesting. So you see, this is the slope. This value minus 0.15. This is the slope. This is the slope, and this is the hour of video game plays, and this is the GPA. What is happening in this math? Let me tell you what is happening in this math. Average Suppose this is what is happening. Um, so what is happening in this math is, if some people, some students plays a lot of video games. Suppose if someone plays a lot of video games, let's say 10-hour video games. If someone plays 10-hour video games, 10-hour video games here, then his or her GPA is 2, CGPA is 2. If he plays just only 5-hour video game, then the GPA is approximately 3. If someone plays 0-hour video game, then GPA is 3.5. That means if someone plays video games too much, then their GPA falls. Their grade point average, their grade in their exams, it falls. It goes down. Okay? And actually this is 10 hours video games, means this is weekly 10 hours, not in a day 10 hours, weekly 10 hours. So what is happening here is, in the interpretation of slope, it means that, slope means change in y divided by change in x. And our answer came minus 0.15, minus 0.15. That means if x value, minus 0.15 divided by 1, if there is nothing down, then there, 1 is downside. So x is 1, y is minus 0.15. It means, this slope means, if anybody plays 1 hour video game, if anyone plays 1 hour video game, their grade point will fall 0.15 for each hour. Fall means minus, go down, okay, which is written here. Each hour of video games played per week is associated with 0.15 lower GPA. That means their GPA will go down by 0.15 if they play 1 hour video games. So if they play 2 hour video game, then what? Then this will be 0.30. If they play 3 hour video game, what will happen? That will be 0.45. I am just multiplying this number by 2, 3 like that. So this slope means this. This slope represents this. Interpret means, what is this slope means in words? In words, what does it means? That is the interpretation. Okay. So there is another question here, which is, predict GPA of a student who plays video games for 6 hours. As I said, if you have this equation, which is the model for this data, this is the model. If you have the model, you have some advantage. One advantage is, now you can find out for any value. I can say, find out if someone plays 6 hours video game, what will happen? Then you put 6 here. I can tell you, if someone plays 10 hours video game, what will happen? You can put 10 here, answer, you will get some answer. So in this math, if someone plays 6 hours, that means here h value is 6. So your math will be, this math will be minus 0.15 into 6, because 6 hours, then plus whatever it is, this is 3.5. Then you just do the calculation, answer is coming this 2.6. This is the answer. So once you have this model, you can actually do the other calculation. This is how model helps us. So what is the benefit of modeling all these things? I already said a bit. If we can model it, actually, then we can predict the future. We can predict the f of x based on the value of x. Or we can actually, f of x means y. We can actually find out the value of y for the value of x. Or even if the value of y is given, we can find out the value of x also. Then we can find out the equilibrium point, supply and demand math related to that, and actually some other maths also where we say straight line depreciation and other things, which we will discuss in some future class in a more application math. That kind of math we will discuss it. The point here is once you have this linear model, you have these benefits. We have these benefits. We can do this math. More math we can do. If we have this model, if we have this equation, then we can do more math. We can answer, we can do more math means what? We can answer more questions about that. Then we can analyze it more in depth. This way, model helps us. Once again, what is model? Model means what? Model means some equation, some function that represent real life situation. Okay, that is called model. This is not model from, let's say, model, not that model. Suppose this is a model for heart rate. In our heart there is some heart rate, heartbeats. So this is a relationship. So this is a relationship for average heart rate for human. Maximum heart rate equals to 220 minus age. 220 minus age. This is the heart rate function. So suppose you know this. 220 minus age. So now if you say, someone says, okay, if someone is 20 years old, so what will be the heart rate? 20 years old, then what is the heartbeat? Then you can put here 20, then you get the heartbeat. Okay, so this way we can actually find it out. Then 30 years old, we can put just here 30. Then what will be the heartbeat? We can actually find it out. And then we can answer more questions. We can extend that from different angles. For example, if we put here y equal to 0, then what happens? This kind of thing we can actually find out. How old a person would have a maximum heart rate of 75 beats per minute. That means we can put here 175. Then we can find out the age. You understand? So if we know the heartbeat of some people, now we can tell their age also. So if someone is not telling their age, now we know how to find it out without asking them. We can ask them, hey, what is your heartbeat? What is your heart rate? Tell us your heart rate. I am not asking your age, I am asking your heart rate. This is some medical thing, Then you can put it in this equation and then you can find out their age. Okay, so see, there are some tricks here. Not good tricks, useful, of course, I suppose. These are the homework. Homework means practice work. These are the practice work these are the maths that you can practice based on today's class, the things that we discussed. So 17, 18, this is related to the linear modeling. Then 3, 4, this is related to scatter diagram. Finding out the linear or non-linear scatter diagram. And you have to read this section 3.1 and 3.2. Please read the book. It is not, I'm sure I will agree with you, this is not interesting or this is not super interesting something, but we have to read. It will give us the benefit later. So please read this 3.1 and 3.2. And that's the end of this record. Thank you all. Thank you very much, and see you all in the class. Bye bye.